Hello, today we're going to look at quadratic functions or quadratic equations and see what the equations produce in terms of the shapes of the graph. So if we look at this one first of all, our basic quadratic y equals x squared. It produces what we call a parabola in maths, and this one is a U-shaped parabola. If it's y equals negative x squared, you're going to graph. Then again we get a parabola, but this time we call it an N-shaped parabola, an upside down parabola I suppose. The way I like to think about this is when it's positive in front of the x squared, so positive x squared, it's a happy face. When it's negative in front of the x squared, it's a sad face, a sad face. Let's move on from there. So this time we're going to look at varying the number in front of the x squared. What happens to the graph? So we're going to have a number greater than 1 and a number between 0 and 1. So our middle graph here is our normal y equals x squared. So if we look at when we make the number greater than 1, so say y equals 3x squared, you can see this graph here is steeper than our original y equals x squared. And when we make the number in front of x squared between 0 and 1, so in this case a half, you can see it's shallower than our original y equals x squared. So when the number is greater than 1, it produces a steeper graph than our original y equals x squared. Number between 0 and 1 produces a shallower graph, or a shallower parabola. Right, moving on. This graph here, I'm going to stick with y equals x squared. And what I've got, what I'm going to do is I'm going to add a number to the x squared. So I'm going to have x squared plus a, and that number might be 1, 2, 3, might be negative 1, 2, 3, and so on. It could be any number. Now in this case, this graph here, the blue graph, is x squared plus 1. So I've added on 1 to my original graph, and hopefully you can see that it's shifted up 1 on the y-axis. And you might also notice that the y-coordinates, if you take the original y-coordinates from y equals x squared, have shifted up 1 as well. So there's 2 examples there. But I think the easiest way to think about it is shifting up the y-axis. So original graph y equals x squared, when I add 1, it shifts up 1. Now what I'm going to do, I'm going to vary a, and we're going to see what happens. So I'm going to add 2, it shifts up 2 from my original y equals x squared. Add 3, shifts up 3. Add 4, shifts up 4. What happens when it's negative, or what happens when it's 0? When it's 0, the graphs just coincide. When it's negative, so say for instance, take away 1 in this case, it shifts down 1. Take away 2, shifts down 2. Take away 3, shifts down 3. So the equation for this particular graph at this point is y equals x squared subtract 3. So the way you could think about that is our original y equals x squared graph, our happy face, it's subtracting 3, so subtracting 3, it shifts 3 down the y-axis, or all the y, an alternative way of thinking about it is all the y-coordinates are reduced by 3. So this number here, the a, if it's positive, we go up the y-axis. If it's negative, we go down the y-axis. Goodbye, and thanks for watching.